Okay, this is going to wrap up the last of our video, 61 through 80. I kind of hit 61 on the other video, which is basically just 14 pi. So let's go ahead and jump into 62. All right, major arc. So there's a lot of different answers, but major arc has to be over 180. So I'm going to go EGK, EGK. Minor arc is less than 180, so just EG would be fine. Semicircle's got to be exactly 180, and you got to use 3 points, so I'm going to use KCG. Central angle, CDG, so as long as our angle has a vertex at the center, we're good. And then inscribed angle, G's on the circle, so we can go KGC. Okay. Okay, so some of these have already been pre-done, but we'll still talk about them. So 63. On this one, the first thing I actually did is I kind of broke up and found all of the arcs first. So I covered the top and I said, hey, I got 62 here. Since this is a diameter going through the middle, I know this has to be 180, so I did 180 minus 62 to give me 118. And then up here, I saw 82 as a central angle, so it's going to be congruent to LJ arc. And then since I had 47 and 82, I knew that this third one had to add up to 180, so we did that plus that plus that made 180. Then we had to go ahead and fill it in. I did the arcs first. KL is 51. HLJ, sorry, is a semicircle, so it's 180. And then we did LJM, so LJM is just 82 plus 118 to give me the 200. And then HMJ is a inscribed angle. It opens up to half of the circle, which is 180, so it's half of that at 90. And then over here, MHJ opens up to 118, so it's half of 118, gives us 59. Number 64, we have two inscribed angles that open up to the same intercepted arc, which means you can set them equal to each other and solve and get x equals 6. Once you have x, it asks you to go back and solve for BC. Well, I don't know what it is, but if I plug in 6 into measure of angle BAC, I get 68. So this angle right here is 68. Remember, inscribed angles are half of the intercepted arc, so I had to double it to get BC, which would give me 136. 65, MAT is an inscribed angle, and MHT is a central angle. So the central angle is equal to its intercepted arc, but then the inscribed angle is only half of that, so I have to divide it by 2 to get 61. All right, 66, our first problem where I don't actually have any work shown. 13 is a radius right there, and so what I can do is I can draw another radius of 13, and this is a right triangle, so we're going to solve for FD, but first we solve for this piece here in pink. So we're going to get 10 squared plus, we'll call it x squared equals 13 squared. And again, we're solving for that number in pink. And I'm just going to do it quickly in my calculator off screen. And we're going to come up with the answer of about 8.3. So if this is 8.3, then this is also 8.3. It gets bisected. And so we just have to kind of double that to get FD. So if you double it, we're going to get 16.6 as our answer. All right, 67, find the perimeter. So if you have a tangent line that meets at a point outside and they're tangent to the same circle, these are going to be congruent. So these are congruent, these are congruent, these are congruent, and these are congruent. And so since we had 14, I knew that was 14, we had 9, that was 9, we had 8, that was 8, we had 10, that was 10. So we just have to literally add them all up. So 10 plus 10 plus 14 plus 14 plus 9 plus 9 plus 8 plus 8. And we get 82 for the perimeter of this shape. So write the equation of a circle in standard form given the center and the radius. So our standard form is actually written right here. So the center is always my h comma k. So we have x minus a negative 8, so that's going to look like a positive 8 squared, plus y minus 9 squared, and then it's going to be r squared, so we're going to get 144. And number 69, we're doing the exact opposite. This time we're taking it out. And so The center, it looks like a -4, but it's actually a +4. It looks like a +7, but it's actually a -7. And then we're going to square root the 18 because r squared is 18, but we want r, so we square root it to get just the 18. Number 70 is one where we're going to have to complete the square. So we want to separate the x's. So we got x squared and 12x. That's what I did here. And then leave an open space that we filled in, but we'll talk about how we filled that in. And then we got y squared minus 4y, and then we left an open space, which can be filled in, but we're going to take care of that. And then we move the 12 away to the other side, -12, and I put two new open spaces. Okay? So essentially what we have here is we need to find this value. And to find that value, it comes from b divided by 2 squared. So what I did is I took b value, which is 12, divided by 2, which is going to be 6 squared, which gives me 36. But whatever I do to one side, I have to do to the other side. Okay, so that's how I got 36 on both sides of the equation. Got to keep it balanced. So same thing over here, we got -4 divided by 2 and then squared, which is going to be -2 squared, which gives me 4. But whenever I put it on one side, I have to put it on the other. So -12 plus 36 plus 4 gave me 28. But then I have this trinomial, which is x squared plus 12x plus 36. I got to turn into a binomial. So I had to ask myself, what multiplies to 36 but adds to 12? So 6 plus 6 is 12. 6 times 6 is 36. So we're going to get x plus 6 parentheses squared. Next, we have what multiplies to 4 but adds to a -4. And so that's going to be y minus 2, because -2 plus -2 is -4. -2 times -2 is +4. And there's our circle equation. Okay. All right, hitting the home stretch here. Next two questions are kind of lengthy, but I talked about a lot of these in class. So anyways, first things first, let's go ahead and graph the HK, which is our vertex and our focus. So I have vertex and focus. Remember, the focus always has to be inside of the parabola shape, whichever direction it's going. Okay, since the focus is below it, the parabola has to be facing downwards, so it will contain the focus. And then we have to combine it with the right formula. So this is the correct formula for a downward-facing parabola. I wrote the one for a right-face parabola for reference. That would be the wrong formula to plug it into. When x is being squared, we're going to have an up or down. And since the 4p is negative, it's going to go down. Versus if y is squared, it's going to go left or right. And here, if it was positive, it would go right. So I basically just plugged in the vertex of 6 and 4 in here, paying careful attention to the signs. And then to get the -16, I had to find the p-value. Well, p-value is the distance between the vertex and the focus, which is 4. So 4p is going to be 4 times 4, which is 16. Then I'd make sure it was negative because it is facing down. All right, and 72. So again, the first thing you want to do for graphing a parabola is figure out which way is it opening. X is squared and 4p is positive, so it's going to open up. Next, let's graph the vertex from our HK, which is going to be 3, -2, and we graph our vertex. Since we know it's going up, we're going to graph our focus upward, but I need to find my p-value. So 4p is equal to 12, which means p is going to equal 3 once you divide the 4 out. So the distance between the vertex and the focus is a unit of 3. And then we do the same thing to find the directrix below it, a unit of 3. So we get the point at 3, 1. The directrix is a line. It hits the y-axis at -5, so the line is called y equals -5. Last thing is the Latus Rectum, which tells me how wide or narrow, do you like that sound effect? Wide or narrow my parabola is going to be. And the length of the Latus Rectum is always equal to the 4p, so it's going to be 12 units in length. And so I don't want to go 12 to the right and then 12 to the left. That'd be too far, so I'm going to go only 6 to the right, 6 to the left. That means the whole thing is going to be 12 units. Okay. All right, number 73. A coach needs to choose 2 players from a hockey team to be captain and co-captain. If there's 25 people on the team, how many ways can he assign the 2 roles? All right, keyword assign, and we have position. If there's positions, we're going to use NPR. We have 25 people, and 2 are going to be picked, but position matters. So we are going to use, again, like I said, NPR. So there'd be 600 ways to choose captain and co-captains. Amy has 10 good friends. She needs to choose 4 of them to be her bridesmaids. How many ways can she choose? 4. Choose is there. Position doesn't matter here. You're a bridesmaid or not. Now, if it said how you're going to line up, that'd be different. So we're going to use NCR. There's 10 of them, and she gets to choose only 4. So 10 NCR 4 gives us 210. Number 75, you reach into a box of crayons, 14 red, 10 purple, 12 green, and 7 yellow. What is the probability that you choose a green? First of all, we got to find out the total number. So there's 43 total, 14 plus 10 plus 12 plus 7. And how many are green? Well, 12 out of 43. And we always try and reduce our fractions. In this case, it doesn't reduce. What about choosing red or purple? Well, there are 14 red and there are 10 purple. Since I'm okay with either one, we're going to add those up. So there's 24 I'm okay with out of 43. Again, I don't think this is going to reduce, but we'll try. 24 out of 43. You can choose a purple, don't replace it, then pick another purple. So there's 2 events happening. So there's 10 purple out of 43, but once you pick that purple, you don't put it back. That's only 9 now out of 42. So we multiply straight across to get 90 over 43 times 42. And that's going to be 1806, and this might actually reduce for us, and it does, to 13 over 301. You choose a red, replace it, and then pick a yellow. Well, red is 14 out of 43. And then we still have 43 because we put it back, and there's 7 out of the yellow. So we get 14 times 7 is 98. And then 43 times 43, which is 1849. And if we divide that, it doesn't break down. So part D is 98 over 1849. Okay, and you choose a crayon that is not yellow. Okay, well, there's 43 total crayons. If we look back, it was 7 are yellow. So 43 minus 7 means there's 36 that are not yellow. So 36 that aren't yellow, and I don't know if that breaks down. It doesn't, so we just leave with 36 over 43. Okay, last page, here we go. So how many ways can a 4-digit password be created? First digit can't be 2 or 3. So normally I have 10 options, but since we can't use 2 or 3, we only have 8 options. And the last digit has to be a 0. So that means the last digit I only have 1 option. The middle ones, it didn't say anything, and it didn't say anything about repetition, so I can use all 10 digits, 0 through 9, and all 10 digits, 0 through 9. So that leaves us with 800. How many different ways can the word infinity be arranged? Well, there's 8 letters, so we do 8 factorial. And then we have to account for all the repeating. Well, there's 3 pink, so we have to multiply or divide it by 3 factorial. And there's 2 yellow, so we multiply by 2 factorial. Okay? 3 factorial is just 1 times 2 times 3, which is 6. And 2 factorial is 1 times 2, which is 2. So we get 6 times 2 essentially, which is 12. 8 factorial divided by 12 gives us 3,360. We'll let you skip number 78. I will have a problem like that on the test, but I'll help you with it. Number 9 of 70, so 79. Why did I say it so weird? I don't know. Chloe purchased 10 shirts, 4 pants, 2 jackets. How many different styles can she choose? So she gets to pick a shirt, a pant, and a jacket. She has 10 for 2 for her options, so we just have to basically multiply all those out. I'm doing my calculator, but I'm pretty sure it's just 80. And last but not least, it's a horribly worded question, but see, flip a coin, roll a die. What's probably of rolling 2 tails? That should say flip. So this is getting a tail, right? So 1/2, and then what is it? Rolling a 6, 1 out of 6. So you just multiply it straight across. 1's on the top, or 1 times 1 times 1, which is 1. 2 times 2 is 4, times 6 is 24. So you get 1 out of 24. That's it. We did it. Fun times. Cheers, mate.